rise in CO2 emissions is not only causing problems on land, but it is having a major effect on the world's oceans. Ocean acidification is caused by a decrease in the sea's pH levels, which in effect has the potential to severely damage particular species in the ocean. Marine calcifiers are particularly vulnerable as the decrease in pH increases the dissolution rates of calcium carbonate, meaning that some of these creatures' shells can literally dissolve. William Christopher Long and colleagues conducted research which I will be discussing today titled The Effects of Ocean Acidification on the Juvenile Red King Crab and the Tanner Crab, Growth, Condition, Calcification and Survival. The aim of this experiment was to determine the relationship between declining pH levels and the long-term effect on these two species. In this experiment, the researchers prepared 3 tanks with differing pH levels, with a control set at a pH of 8. The 2 remaining tanks were set at a pH of 7.8 and 7.5, the latter expressing the estimated level in years to come. 90 crabs of each species were distributed between the tanks evenly. They were each placed in a holding cell so that they were easily identifiable and so that the crab smolts could be retrieved and studied. The experiment lasted a total of 199 days for the Tanner crabs and 192 days for the Red King crabs. Each crab was measured, as shows in this diagram, at the beginning of the experiment, after each molt, and at the end of the experiment. This was to get an idea of the growth differences between the control group and the different pH levels. Both species were recorded to grow more slowly in the lower pH water. The Red King crab was the most sensitive and showed a dramatic change in growth in the 7.8 pH level. However, as it shows in this graph, the Tanner crab only showed a dramatic growth change in the 7.5 pH tank, and not much of a change was noted in the control group and the 7.8 pH tank. The most serious and negative side effect that the researchers found was an increase in mortality rate. This was especially noticed in the Red King crab, as all of the crabs in the lowest pH tank died after only 95 days. Although the Tanner crabs did not all die, it was noted that they too experienced a much higher mortality rate at the lower pH levels. Long and colleagues concluded that the predicted ocean acidification in the near future will indeed have a profound effect on the 2 crab species studied. The decrease in size, whilst might not appear to have any major effects on the condition of the crab, it will make them more vulnerable to predators. The increase in mortality, combined with the decrease in size, will affect both of the populations. However, it's not yet determined if these species will be able to adapt in time to the changing pH levels around them.